Hi everyone, I recently posted onto the Instagram a challenge which was made by myself, and it goes a little something like this. We've got a hexagon and there's a line y equals minus 9 over x plus 9, and it passes through the midpoint of AB. That's just down here. What we also know is that point A has the coordinate 5, 0. And the shape A, B, C, D, E, F is a regular hexagon as said before. Regular meaning that all of those sides are equal. Angles too, let's see if we need to use them. But what we did here was that point A was 5, 0. Let's label that now. Basically, would they put this equation in there if you didn't have to use it? Probably not. So how could we use that equation to find something more? Well, because all of these sides are exactly the same, it would be nice to know what that halfway point was, because that would be halfway towards B. And if we knew what the halfway point was, we'd know each of those sides of the hexagon. Could be very useful. Let's look at the focus of our question though. Find the coordinates of point D. Okay, well, question you ask yourself straight away is, can you do it right now? You can tell a number of things about these coordinates. First one is E. You can see that it's this, which doesn't really tell you much more. You know that it's in line with the A down the bottom. That's about it. Let's start with the equation and see where that gets us. It says that it passes through the midpoint of AB. So let's draw it roughly on the diagram to give us an idea of what's going on. Now we've got a line to help us get a visual on this. Let's see if we can figure out and focus on a point that is really important, this midpoint. The midpoint on this line is a special coordinate which we know something about. We know for sure that it has a y coordinate of 0. What we want to know is the x coordinate at that point. So let's put the y equals 0 into the equation and see how that works out. So now that's in, all we need to do is rearrange. I think we'll shove that negative over to the left first. Next, we're going to multiply by 8. And then we're going to divide by 9 to get x alone. So now we found that x is 8. Let's put it back into the diagram and see what it means for us. We can tell that this distance here is going to be 3. And because that's the midpoint, we know the other side is also 3. Which leads us to be able to conclude about what B is. And thankfully, that's useful to us because B is in line with D. Knowing a little bit about D is helpful. Let's have a look at what that is currently. We're still missing that Y value. Be really interested to know how we can get to the height of D. Is this something to do with the hexagon, the internal geometry that we could use? Yes, there is. If we split this hexagon internally with the lines to the vertices, as you see, we get a number of isosceles or equilateral triangles. Each equilateral triangle can be split down the middle to give a length of the height. If you look on the right, we can see that the drop down the center has created the right angle triangle to the right and to the left. And if we label these sides, we can see that we've got enough information to use Pythagoras. We'll just go ahead and put that into the relationship, rearrange and get h on its own, and simplify on the left hand side. I think we can do a little bit better. We simplify again. So the value of h is important to us because if we go up 2 of those, we'll get to the height of y. So we've found what we want. It's not in the perfect whole number integer, but we can still write the expression for it as follows. And the only thing left to do after that is to put it into what they were after, which is the coordinate of the point D. So we'll just do that in a different color on the right. Thank you so much for watching, and I hope you enjoyed doing this problem as much as I did. And while you're here, think about subscribing. It's free and I'd love to have you around. See you in the next one.